Welcome back. Let's talk a little bit more about charges on ionic compounds. So when we have an ion, right, the charge on an ion depends on what group it's in. Remember, the groups reflect the number of valence electrons. The groups are up and down. So anything in group 1 has one valence electron. It's going to lose that electron to become plus 1. Group 2 will be plus 2, right? Group 17 minus 1, 16 minus 2, and 15 minus 3. If we have a polyatomic ion, those charges are on table E for that ion. There's a few elements ions we haven't talked about here, such as the transition metal ions. Those can have varying charges, and we'll talk about those in a minute. You might want to write these charges above each of those groups on the periodic table. You can pause the video to do that. What if we have a transition metal? Transition metals can have various charges. There's a few exceptions. Zinc only ever takes on a plus 2 charge. Silver only takes on a plus 1 charge. You can see those charges on the periodic table in the spot for the oxidation number. Oxidation numbers are a little different than charges, but for now we'll kind of talk about them as almost the same thing. If you look at the copper box, copper can take on both a plus 1 and a plus 2 charge. We use a Roman numeral to tell us what charge it is. So copper, Roman numeral 2, means 2 plus. Chromium, Roman numeral 7, means 7 plus. And lead, Roman numeral 4, means 4 plus. You should be familiar with the Roman numerals 1 through 7. How about each of these ions? Could you write the charges in for the symbol and charge for each of them? You can pause the video and try that now. Now, we usually won't have an ion just by itself because we need both a positive and negative ion to kind of correspond with each other, total charge of 0. So if I give you a formula like MgCl2, you want to be able to think about the ions that make that up. If you're thinking Mg2 plus and Cl minus 1, you're on the right track. We're going to talk exactly how you do that in a moment. But the same idea is true here. Calcium 3 plus is made up of 3 calcium 2 plus ions and 2 PO4 3 minus ions. Let's talk a little bit about exactly how you do that. Here's the steps. So what we're going to do is we're going to use the charges that we know are true first. So we know that everything in group 1 is a plus 1 charge. So above K, we can write in plus 1. Above Cl, we know Cl is in group 17, and everything in group 17 is a minus 1 charge. Remember, even though there's many oxidation numbers for chlorine, we're not really talking about oxidation numbers right now. So the only charge we're talking about for negative ions in group 17 is minus 1. Calcium fluoride also has some known charges. Calcium's in group 2, and it's 2 plus. Fluoride is in group 17, and it's minus 1. In the first example up here, it was easy to see how this adds up to 0. Perhaps it's a little more difficult here. What we're going to do here is we're going to keep track of the total on the bottom. So calcium has a charge of 2 plus. There's 1 calcium. So all the calciums in this formula have a total charge of plus 2. Fluoride, has a charge of minus 1, and there's 2 of them. So we're going to say all the fluorides in this compound have a charge of minus 2. Notice that that adds up to 0. For all compounds, unless otherwise indicated, the charge will total 0. This one's a little trickier because iron can be plus 2 or plus 3. Let's tackle the sulfate first. Remember sulfate? It's one of the polyatomic ions on table E. If you look on table E, its charge is 2 minus. When I say you need to be familiar with the ions on table E, this is kind of what I mean. You won't really know that it's sulfate unless you're familiar with those ions. One trick is this. For all the writing and charges, we're almost always only working with 2 ions, one positive one and one negative one. So many of the polyatomic ions are negative, so I can look at that table E and figure out that SO4 2- is the 2- is the charge on that. There's only one SO4 here, right? In every one SO4, there's one S and 4 O's, but there's only one SO4, so the total charge here is -2. What's the charge on iron? Well, the reference table says it could be +2 or +3. How do we decide? Well, we know that this charge has to equal 0. What number plus -2 gives you 0? That's right, +2. So the charge on iron here is +2. Remember, when I'm referring to the charges, I'm referring to the top numbers here, +2 and -2. When I'm referring to the total, I'm referring to the number down below. How about MgOH2? Well, Mg is in group 2, and it's 2+. OH is in group polyatomic ions, and it's -1. +2, there's one magnesium. The total here is +2. Plus OH- times 2 minus 2. This also totals 0. You're going to be writing in this total for a long time here because we always want to be illustrating that it equals 0, even if you think you can do it in your head. This one's the most complex example yet. Fe has an unknown charge, as we talked about over here. So SO4 has a charge of -2. That's on table E. -2 times 3, that gives me a -6. Notice that I'm not multiplying by anything that's in this highlighted piece here. Okay, that highlighted piece that I'm going to now erase, maybe erase. I can only erase it all. That highlighted piece is going to be all SO4. That 4 doesn't get multiplied by, right? Because right on table E, we can see that that whole SO4 piece has a charge of -2. So -2 times 3 is -6. That means all the irons must have a charge of +6, right? How do we figure out the charge on the iron, though? It's not +6. That's the total. That's right. I have to do 6 divided by 2 to give me +3. So the charge on iron here is +3. Why did I fill this in with +6? Well, I knew this total had to equal 0. Next up, we're going to write some formulas, so stay tuned for the next video.